let's continue with some more examples of homomorphisms. So what happens if I want to find now all homomorphisms from Z mod 14Z to Z? So now this is the group G, right? And this is the group H. So am I in case 1 or 2? I am in case 2. A generator of this group is 1 plus 14Z. So the order of Z mod 14Z is 14. So we're in case 2. So that means, so there exists so by proposition 4, there exists a homomorphism phi from Z mod 14Z to Z such that phi of 1 is equal to H if and only if the order of H divides 14. Okay, so I'm only allowed to look at integers whose orders divide 14. But what are the orders of elements of Z? 0 has order 1, and everything else has infinite order. So the only thing I can allow here for H is 0. So there's only one homomorphism. One homomorphism. Namely, phi of 1 equal to 0. As 0 is the only element of Z with finite order. Right? For this to be true, that thing has to be finite. So there's only one element of Z with finite order. So that there's only one homomorphism. That's the 0 homomorphism, the trivial homomorphism. Everything gets sent to 0. Well, again, if 1 is sent to 0 in a cyclic group, that determines where everything else goes. But if 1 is sent to 0, then 2 is sent to twice 0, so 0. 3 is sent to 3 times 0, and so on. All right, let's do another example. Let's keep the Z mod 14Z, and actually, no, let's change it to something different. Let's do Z mod 15Z to Z mod 3Z cross Z mod 3Z. All right. Oh, this is not a cyclic group, you say? But you see, that doesn't matter, right? Because this plays the role of H here, and H is just any group. This is the important thing. This must be cyclic. And it is. It's generated by 1 plus 15Z, and the order of Z mod 15Z is 15. So again, so let's just write this sentence again. So by proposition 4, there exists a homomorphism phi from Z mod 15Z to Z mod 3Z cross Z mod 3Z such that phi of 1 plus 15Z is equal to H in Z mod 3Z cross Z mod 3Z if and only if the order of H divides 15. Actually, right. Okay, so which elements have orders here that divide 15? What are the possible what are the possible orders? Remember, what is this? This is A plus 3Z, or let's write it like this. It's A comma B, where A and B are in Z mod 3Z. What are the possible orders of elements here? You see, we've done this example before, that when you add when you add this to itself 3 times, you get 0. So the orders are at most 3, which means the possible orders are they have to divide 3. So the possible orders are 1 and 3. So every element here, note, every element of Z mod 3Z cross Z mod 3Z has order 1 or 3. But 1 and 3 both divide 15. So that means there are 9 homomorphisms, 1 for each element of this group. So there are 9. So there are 9, not 3, but 9 homomorphisms. So you can say phi A B from Z mod 15Z to Z mod 3Z cross Z mod 3Z, and phi sub A B of 1 plus 15Z is going to be A comma B. There's one homomorphism for every element of Z mod 3Z cross Z mod 3Z. So very often finding out these homomorphisms from a finite cyclic group here to a group there is to actually, it really boils down to finding the orders of elements here. So let's now change this group there and let's look at Z mod 3Z cross Z mod 2Z. So we'll change that. And let's we'll compute the orders of elements there in the next video.